Hello, fellow foodies, and welcome back. This is Dr. Cassandra Quave, and you're listening to Foodie Pharmacology, the science podcast for the food curious. This week on the show, we're going to touch on a really fascinating topic, and that's the topic of agrobiodiversity and climate resilience in Ethiopia. This Foodie Pharmacology podcast is part of a special series co designed with the Periodic Table of Food Initiative, also known as the PTFI. The views and opinions in this podcast are those of the presenters and represent the synthesis of science. The PTFI is a program of RF Catalytic Capital managed by a collaborative team at the American Heart Association and the Alliance of Bioversity CIAT that seeks to advance our fundamental understanding of food composition by providing tools, data, and training to scientists across the globe so they can better characterize the quality of the world's edible biodiversity. The PTFI's ultimate goal is to advance data driven solutions in the food sector for the health of people and the planet. Funding for the PTFI is provided by the Rockefeller Foundation, the Foundation for Food and Agricultural Research, C-RAVE Foundation, Fourfold Foundation, and Atria Health Collaborative. Now, our guest today is a friend and colleague who I've known for a number of years, and he's doing some really exciting work in this domain of agrobiodiversity and conservation. Dr. Alex McAlvay is an ethnobotanist at the New York Botanical Gardens Institute of Economic Botany. His research focuses on understanding the relationships between humans and their environments, the evolutionary and ecological impact of humans on plants, and the traditional stewardship of plants by various cultures. His work has included projects in Mexico, Ethiopia, the United States, and elsewhere, with a focus on food sovereignty, agrobiodiversity, and the continuity and revitalization of traditions related to plants. He also teaches an ethnobotany course at Columbia University. He obtained his bachelor's from Western Washington University and his PhD from University of Wisconsin-Madison, and completed a postdoc at Cornell University before joining New York Botanical Garden. Alex, thanks so much for coming on the show. It's great to see you.
You for having me. This is really a pleasure.
I'm excited to learn more about the work that you're doing now. I know you're working on a really interesting project in collaboration with the Periodic Table of Food Initiative on the topic of agrobiodiversity and climate resilience in Ethiopia. What can you tell us about this project?
This project is focused on understanding traditional strategies that farmers have in Ethiopia for dealing with uncertainty in terms of weather, pests, pathogens, and other challenges. So the project is based on the idea that this isn't the first time that people are encountering drought and the first time that they're encountering new pests or threats. And people over thousands of years, thousands of generations even, have developed these locally adapted tools and strategies to deal with this. And they often hinge on diversity. So using plant diversity to hedge your bets, kind of an insurance policy against what we can't predict. Strategies that are used all around the world. And so especially we're focused on a strategy of mixing. So you mix several different crops in the same field. One benefit is you're not putting all your eggs in one basket. You've got a crop that's resistant to drought and a crop that's resistant to flooding. So if the year is a wet one or a dry one, you're not as worried. And then the other part is that some of these components of these mixtures work together. One might be stronger or sturdier and hold the other one up so it doesn't fall, rot in the mud. The crops we're studying right now are mixtures of wheat and barley, mixtures of fava beans and peas, and then mixtures of two important Ethiopian crops, Tef, which is a local grain that is native to Ethiopia, the smallest cultivated grain in the world, and as well as sorghum. And sorghum is the second most important grain crop in Africa. We see it in the US, sometimes called broom corn or greater millet. And so that's the project. We're looking at nutrition of these mixtures. We're looking at how they do in the fields, so their agricultural performance. And then we're looking at a traditional knowledge around these mixtures, how to make them and why plant them.
This sounds really fascinating. If you compare this for example, to a traditional industrial ag environment. How does this compare? What are the main differences?
Agriculture has been on a trajectory in the last 100 years towards more consistent, uniform outputs, towards mechanization, towards heavy inputs, and by input, synthetic fertilizer, lots of water, pesticides, etc. Whereas a lot of traditional systems around the world are more self-sufficient or self-enclosed. So the outputs from something like manure from cattle go back into the system as fertilizer. But really, the diversity part is what characterizes these and sets them into high contrast with industrial systems. So sometimes a farmer will plant 3 or 4 different varieties of barley mixed with 2 different species of wheat. And within those species of wheat, maybe 2 different varieties each. So a total of 6 or 7 components. Some of the sorghum mixtures have a dozen or more different varieties.
Wow.
The farmers will intentionally choose which varieties to mix in what proportions to accomplish certain goals or anticipate certain challenges that year. Another big difference is this is a strategy developed by and for smallholder farmers. By smallholder, family farmers who are mostly growing food for themselves and a little bit for markets. Their motivations and incentives are very different than a large industrial farm. For example, in the US, if you're growing a crop and it's a bad year, you can collect your crop failure insurance. There are various subsidies to bail you out. But in the case of a smallholder farmer over many thousands of years, you have to think about resilience a little bit more. And for the industrial farmer, if you have really good crop and a really good year, you're set. But if you're a smallholder farmer, you can't afford to have a bad year. We are thinking that it's a good time for us as a whole, as humanity, to relearn that lesson that resilience is important because the good years are getting fewer and further between.
Yeah, I mean, with changes in rainfall patterns and drought and pests that come out and affect our crops. So it's really almost nature's insurance, but this is a traditional form of agriculture that's been used for a long time.
Exactly. Yep.
Great. So who are your partners on this project? Who are you working with? And how does, you're based in New York. How does this work to undertake such a large project in another country?
Yeah. Great question. So we're working with the Ethiopian Public Health Institute. They're doing the nutritional analyses and providing in-country support in terms of foodways and the nutrition of different dishes. So various fermented foods we're looking at. For example, we're working with Addis Ababa University in the capital. And through them, we have great partners, but also PhD students. So those 4 PhD students are doing interviews with farmers in the region we work in. We work with Wolo University, which is a more agricultural university. And we had 4 master's students there who are doing agricultural experiments. And then we have a range of other partners throughout the US. We have professors at Clark University, Cornell University, and City University of New York, as well as graduate students at some of those institutions. And it's worked very well. And the most important thing is that this project has come out of past collaborations with a similar group. So we've established our trust and our working relationship, and we enjoy each other's company. We've just been chomping at the bit, looking for the next opportunity after COVID to work together again.
Yeah, that's great. Well, and I guess one last question before we move on is how do you working with these partners, how do you identify which communities to work in? Like, how do you know which communities are working or growing these diverse crop mixtures?
It takes a lot of kind of foreknowledge to make sure you're not just wandering around knocking on people's doors.
Yeah. Do
Not
you
in a
grow this? Do you grow that?
or yelling out of a car window. What's lucky about having so many local partners, for example, the Wooler University group. Wooler University has extensive agricultural extension work network. So they have researchers and practitioners going out to communities regularly, taking tallies of what people are growing. So we have that. In 2018 and 2019, I did some interviews doing just that, knocking on doors. And so we have some idea of who grows the wheat and barley mixtures where. And there were a lot of places I didn't find it, and especially a lot of places that had grown it 10 or 15 years ago, but had stopped.
Historically, are wheat and barley the most important grain crops of this region, or is there something else that was used historically?
So wheat and barley are very ancient in Ethiopia. We might associate wheat and barley with kind of the Fertile Crescent area, Mesopotamia, but very early on, it came down either through Egypt or around through Yemen down to Ethiopia, where Ethiopians really made it their own and they diversified it in interesting ways. So it arrived there, and like many crops in Ethiopia, it just exploded in diversity. And that diversification is a combination of the crops reaching new environments. So there are highland and lowland, subtropical and montane areas in Ethiopia, and different tastes. So there are different uses for plants. There are different taste preferences of different cultures. There are many dozens of almost 90 languages in Ethiopia spoken. So there are as
Wow.
many cultures and as many tastes and preferences as there are people in Ethiopia. It's been a flourishing or flowering of diversity there.
Incredible. And when I think of Ethiopia, my mind always goes to coffee because this is also one of the centers of coffee diversity as well. When you worked in Ethiopia, did you have a chance to taste some of those local coffees?
I did. Yes. It's has an amazing coffee culture. Many people will stop for coffee 3 times a day
Wow.
and stop everything they're doing and sit down and have the coffee ritual or ceremony. You might be interested to hear that it's often served with a sprig of ruruta, not Ruta graveolens, the European
Uh-huh.
one, the native species, and it gives the coffee an interesting taste. There's also a lively espresso culture there due to the brief Italian occupation. And the best macchiato in the world that I've ever tasted was in Addis Ababa University.
Great,
Yeah.
that's great. The best macchiato I've ever had is in Pristina, Kosovo. So we'll have to put those to the
I'll
test.
have to, it'll be hard to get them side to side in one place.
But yeah, it'd be difficult. We could do a road trip or a plane trip. Okay, so one of the, I think, interesting things about your work on this project is looking at many different factors. You're looking at cultivation of combinations of different crops with the end goal of local farmers of ensuring that they have a harvest. You're also looking at this nutritional data in collaboration with local partners at the university. What can you tell me about some of the multi-omics components of this study? I think that's where the PTFI or the Periodic Table of Food Initiative plays such a big role. What can you share with us about that? And why is it important that we understand these crops from these multiple kind of omics levels? And maybe we can dive into a little bit more about what omics is because it can mean many large things.
Yeah. So the omics approach or Omics Revolution, it is very encompassing of many types of omics. One is genomics, which might be the
Mhm.
most familiar to people, looking at the whole genome or large chunks of the genome. Metabolomics is probably familiar to some of you who are familiar with phytochemistry or medicinal plants, looking at these secondary metabolites or metabolites of plants in a more comprehensive way than just going after one particular type of molecule. There's ionomics, looking at minerals or certain elements in plants or other material. So the basic premise of the PTFI, one of them, is that nutrition and food composition research should go beyond these kind of basic macronutrients and a typical panel of micronutrients. So all too often, analyzing food, we just look at protein, fat, carbohydrates, and then vitamins A through Z, and then iron and zinc, and et cetera. That leaves out not only a lot of interesting minerals, for example, but also a lot of health promoting complex plant derived compounds. As we know, we're probably familiar with a lot of health promoting compounds like antioxidants. So in your red wine or your blueberries or your acai bowl. But these compounds are in all different plants and they're not as well understood as they should be. In the case of our research, we're very interested in these because when you think of wheat and barley, you might not think of antioxidants particularly or beta
Mhm.
carotene or things like this. But in some cultures where the staple grain is really the cornerstone of the diet, where wheat and barley, for example, comprise a large portion of what you eat, it is important what these nutrients are. So in this picture, and I can explain it for those who are just listening, we have simple white wheat that the farmers are encouraged to grow. It's promoted as an exportable wheat variety. And then on the right hand side was a mixture. So this is the traditional mixture from one farmer in Wollo, Ethiopia, where you have these black barleys. They're these deep black barleys. There are these kind of pomegranate seed, red ruby
Mm.
wheat. There are barleys with kind of a lot of bran on them. This is not a minor difference between what
Yeah.
farmers have grown in the past and what they're being encouraged to grow now to support the scaling up or increased production of wheat. And
That's
so we're really curious.
interesting. So those dark colors, going back to antioxidants, just to break this down for folks, when you have any black or deep purple or deep blue or deep reds, those are due to molecules known as anthocyanins, which are in the subclass of flavonoids, or all these fancy words. But basically, when you hear this term, eat the rainbow, and especially eat those dark blues, reds, blacks, those are plant materials that have very high concentration of these anthocyanins, which are potent antioxidants. And we know that antioxidants are good for our health. This has been shown again and again to help limit the damage from reactive oxygen species or free radicals in the body. So this is interesting. We're not just talking about bleached white wheat, like the standard type of wheat that's sold on the international market, but instead we have a composition of a mixture of grains that you're saying are rich in these molecules that we would normally only find like in our blueberries and our eggplant skins and acai, et cetera. That's fascinating that it can be in a grain.
Another example is with sorghum. So this is slightly different, but sorghum is an interesting crop because some varieties contain a very high level of tannins
Uh-huh.
and also a compound called durin. And so these are tannins are complicated, and Cassie knows a lot more about them than I, but they can be health promoting, but they can also be anti-nutritive and bind up other nutrients.
They can lead to protein deficiency. As you're speaking about tannins, I'm looking on the floor nearby my desk. I kind of want to get up and go grab it, but I have a basket full of acorns that my kids and their friends picked this weekend off the ground because I want to try and make acorn bread. And of course, acorns are rich in tannins, so I have to figure out how to leach them into some kind of clay slurry. I teach about this, but I've never done it in practice. There are some challenges with handling tannins for
You,
sure, but they can make
you,
delicious foods.
one of the approaches I've heard of is the toilet tank method, where
I'm afraid to ask.
you, you chop them up. You don't put them in the toilet bowl. You put them in the toilet tank, and every time you flush, it flushes out tannins with them.
Okay.
And you can just retrieve them from the back. It's just saying.
Okay. So I'm not sure I'm going to be able to convince my teenagers to, hey, eat this acorn bread. I just left it in the toilet for a couple of weeks.
You put
It
it
was a
out.
good way to change out the water. That makes I
It's
could say.
low sustainable. You don't have to boil
Yeah,
it for a long time.
I like that. It's an eco-friendly version of it.
But
We'll see. I may look for some other options.
but with sorghum, what's interesting is farmers will plant a mixture. They'll plant some that have high tannins and some
Nice.
that have low tannins. High
Mhm.
tannin ones deter the birds. Birds don't like the taste. And so if it's a bad year for birds, then they'll at least have these high tannins. But if it's a good year and they don't have a lot of birds, then they have more delicious, more nutritious sorghum. It's just an example of these balanced trade-offs that these mixtures allow. And some farmers, as I mentioned, have a dozen or more varieties. They might have the bird resistant but not tasty one, the tasty one that's not bird resistant, the one that's resistant to locusts because it's a really
Mhm.
head and the locust can't burrow into the middle, and then the one that's resistant to fungi but susceptible to locusts because it's spread out and allows airflow, but the locust can get to every single one. So it's really
Oh.
this multi-dimensional thing. And the farmer thinks, okay, it seems like it's going to be a bad year for fungus because it started raining early. I'm going to plant a lot of these loose ones. And it's a knowledge base that's been generated for millennia. And there's a risk when you throw it all out and just assume that what crop breeders are testing for 3 or 5 years is going to replace these mixtures. We should at least look into these things before we dismiss them as something backwards or something.
100%. As you're speaking, I'm thinking of some of the crops that we know we are at great, they're imperiled at this point because of lack of genetic diversity. If you look at clonally propagated Cavendish bananas, there's the banana apocalypse that's upon us, listeners. If you don't know about this, there is a fungus out there. It's
Eat them
tropical
while you
yeast number
can.
4. Yeah, eat your bananas while you can. And what's crazy is this has already happened before with the Grand Michel or the Big Mike banana, and that's why we have the Cavendish now. And believe it or not, bananas that you can find in places like, for example, in Africa, have large seeds, like real bananas, not the ones that we see in the store. But yeah, genetic diversity is paramount. I love this idea of incorporating crops with different traits that can build upon one another, again, through supporting resistance to pests or, like you said, to locust or tolerance to drought. It's all about ensuring that you have a crop. We see this also in the Amazon. If you look at like bitter manioc, you think of the high levels of hydrogen cyanide. Like, why would anyone grow something that's rich in cyanide that causes cyanide poisoning? They have to process it intensively afterwards to remove the cyanide to have a food. But it's all about, yeah, ensuring that crop. Maybe we're missing that bigger picture. I think in ever since the Green Revolution, which of course, when you hear Green Revolution, you think, oh, it's an organic. No, the Green Revolution is not about organic food. Yeah. I guess one question that goes beyond this. Okay. So you're looking at this now with small scale farmers. Are there any translatable lessons? Like, how do we take these lessons that these farmers have passed down generation to generation over centuries, over millennia? How do we translate that on a larger scale for the growers of food that feeds the world, like on the industrial scale?
Yeah, that's a great question. That's the $1 trillion question. So I guess the case with the grains is interesting because some traditional knowledge is highly specific and localized. And of course, this is, but there are pieces of it that run through a large part of the planet. So using diversity to address food challenges was a human universal until very recent, and specifically using small grains or mixing grains together in the field. We recently published an article reviewing the instances in Europe, Asia, and Africa of people planting mixtures of grain. So wheat and barley, or wheat and rye, or barley and oats, for all of the same reasons. So it's an insurance policy. They complement each other. We have records going back to the 1800s in Scotland of people saying, oh, if you mix them together, there's less fungus. Or we have cases in Greece where farmers were mixing wheat and barley and saying almost word for word, though translated, the same things that the farmers I interviewed in Ethiopia said. So the small grains mixtures approach offers a potential for scalability as well, and could be incorporated into our current systems fairly easily, I believe, because we've had the technology to separate wheat and barley for 100 years or 120 years or more
Wow.
with machines. It's not as challenging as trying to mechanize corn, beans, and squash, which is the classic polyculture or intercropping or
The
mixed
three
cropping,
sisters.
the three sisters, which you can't run a combine through in the
No.
same way and harvest. And then the the wheat and barley, that there's no reason you can't just harvest it the way you'd harvest another small grain crop, but you'd have this added bonus of climate resilience. I think that in this case, there's something to be said, and something also to be said of that this kind of tradition in general of grain mixing is kind of shared human heritage on a scale that's different from a lot of people's ancestors would have been doing this, which is
Yeah,
interesting to think about.
that's fascinating. Well, another question, I'm gonna lean on your botanical background and expertise, is we're talking about these different grades. We're talking about wheat, barley, sorghum, teff. Are these closely related plants? What kind of common characteristics do they share, or do they share common characteristics? Like, and how does that translate to flavor and nutrition? Those are a
Yeah.
lot of questions. Sorry.
No, no, yeah, great questions. What we find fascinating about these mixtures is if you look around the world, you often see these mixtures like I just described with the Three Sisters, where there's a legume or a bean family member, and then a cereal or a grass family member, corn and beans. This is a real obvious pairing because the bean fixes nitrogen, which the cereal needs. The cereal might provide physical support for the beans to climb on. It's a natural fit. But there's the other far end of the spectrum where people are mixing varieties. So, like teff, you're mixing different varieties of teff, or sorghum, different varieties of sorghum. This is within the same species, one single grass species, multiple varieties. So, by varieties, just how dogs have different breeds, and heirloom tomatoes, you have hundreds of varieties. This strategy of wheat and barley, for example, we also are studying fava beans and peas. This strategy of mixing a grass with a grass or a legume with a legume is much less common. And we went into this thinking, okay, so why would you choose this kind of intermediate strategy versus one of these other extremes? And the one extreme of the really different beans and corn, for example, is they're so different that they're complementary in some kind of way in how they grow. The benefit of the variety mixture is you might have one that's drought tolerant, one that's less drought tolerant, but is resistant to birds, for example. That's kind of insurance policy one. So you have complementary versus insurance policy strategy. So we're curious about this intermediate strategy and what benefits it for it. And that's one of the goals of the project, to find out.
Nice. One common theme I'm hearing across all of your descriptions, Alex, is the interdisciplinary nature of your work. And I guess all ethnobotanists, in a way, in our very title, ethno and botany, we're talking about people and plants, and that, of course, takes different skill sets. But I'm wondering if you could reflect on what are some of the challenges and opportunities to taking this interdisciplinary approach to understanding food systems.
That's a great question. And there are many challenges. As I'm saying, so for example, our team, we have experts in nutrition and phytochemistry, experts in agronomy and agroecology, and experts in ethnography and ethnobotany. And we were all at the same table in July trying to iron out every detail of our protocols. And it's not just the jargon that gets in the way of these different fields, of different terminology about, I don't know, who knows what, isoprene units or something, terpenoids, but also just fundamental ways that science is done, how questions are asked, what kinds of sample numbers to use. So, how many people you interview, is that interchangeable with how many grains you mash up and nutritionally analyze from a statistical perspective? Maybe it is, but we have to figure out what the norms of these fields are and reconcile everything. So, it definitely is a barrier, but this is research at the same time that wouldn't be possible without bridging or building a few bridges. So it's definitely a challenge.
Yeah, I like to think of it as being multilingual because in my own work, I cross botany and obviously a lot of chemistry and kind of biomedical experiments and ethnobotany or a little bit of anthropology in there. And it's really, I think, about the ability to speak with people in those different languages because those each field does speak a very different language. As you were saying, terpenoids, isoprene, that's like little music to my ears. I can like, oh yes. But for someone that focuses more on, let's say, the ethnography, it might be like, what is that? It's understanding how to speak those languages and see the bigger picture of how things come together. I think you're doing an incredible job in that with this project.
Thank you. Yeah, I often feel as an ethnobotanist that my depth in any of those three areas is not the same as my collaborators who are, but I feel like I can float between them and understand at least the important piece.
I like to describe it as being a horizontal scientist, and then I collaborate with vertical scientists,
I
meaning
love
that these are like float across fields, and then we really dive in deeper with collaborators that have nuanced expertise in a specific gene system or in a specific compound class, et cetera.
I
Yeah, I
think
think
it's more
that's
fun.
It is. It is more fun, and we get more variety and
Don't get
and
bored.
get to, like, work with a lot of interesting people. It's great. Well, foodie pharmacology, beyond being about plants and agriculture and chemistry and health, is also about food. And I'm sure many of our listeners would love to hear about some of the recipes that you've encountered or some of the types of dishes you've encountered with these different grains. I'm curious in particular about teff and what does that taste and how is that used as a staple in Ethiopia? I think when I think of grains of Ethiopia, I always think of teff like as the top of the list, but as you explained, these other crops like wheat and barley also have a very long-standing presence there. Yeah. So, do you have any favorite dishes that you've encountered on your travels?
Yeah, so many of them. For reference, as I mentioned, it's super small. If you think of chia seeds, maybe you're familiar with chia
Oh,
seeds,
yeah.
like chia seed size or smaller. And one of our master students who's studying teff had to separate by hand the white teff from the red teff from a big batch to plant, which
Wow.
is
With like
hard to
tweezers,
do.
how did they do it?
Yeah, with good eyesight. But in any case, that presents if you go to Whole Foods and buy a bag of teff, it's kind of hard to know what to do with it. Grind it up, or do you cook it whole? But it's most common eaten injera.
Mhm.
Injera is a bread that maybe some would compare to a crepe. It's a flat bread that is fermented. A lot of people who say that they've tried to make it outside of Ethiopia say it doesn't taste the same. And we're interested in this question of whether cultures, the actual cultures of bacteria and yeast, are something that comes from the environment in Ethiopia and gives it its unique flavor. But it's very gently sour. People mix in sorghum or wheat and barley into it. It's eaten with the hands, with the right hand specifically. Kind of rip off a piece, munch it up, and grab a little bite of food, and it's delicious. There's a food tradition called gursha, where you take that little morsel and you put it in someone's mouth, a sign of respect or friendship.
Oh, that's nice. You don't do this with strangers, I'm guessing
No,
then.
no,
Mm.
and more fun when you're expecting it, and that when it's but
Surprising.
and the thing about the wheats and barleys is that there's a series of fermented foods made from them. There's a thick, rich, nutritious beer called tella, which is almost a porridge-like consistency and a low alcohol content. And then there's araki, which is a kind of a moonshine type whiskey beverage. And that's made with the mixtures as well. Yeah, it's a huge range. There's a big, very good trail mix type food called kolo, which is popped. So you take the seeds of the mixture and roast them together. You can carry it with you. It's lightweight, fills you up. You can mix in safflower seeds and roasted chickpeas, and it's just very hearty. The teff specifically has this really nice nuttiness. It's an amazingly nutritious food too. Has 8 times the has some nutrients compared to corn, for example. It's really densely packed.
I
So,
love eating injera. It's one of my favorites. There's an Ethiopian restaurant near my house, so I tend to stop there
oh,
once in a
lovely.
while. And one of the things I noted in a lot of their dishes, they include jalapenos, and I was like, are jalapenos also used in Ethiopian food, like in Ethiopia, or is this more of an Americanization of the dish?
I'm trying to remember. I don't know if I've seen jalapenos. There are a wide range of peppers in Ethiopia, just like these other crops. When they arrived in Ethiopia, farmers made them their own. And I haven't had too much that's spicy, but often, yeah, you get an injera with some nice stews on it and then a big jalapeno pepper
Oh,
to choose your spiciness level.
that's
Yeah.
great. Well, this is making me hungry.
Oh,
We're getting close to time here, so I just wanted to wrap up and maybe you could tell us a little bit about next steps on the project. You've mentioned documentation of the crops that people are using, nutritional studies, omics studies, you expanding upon with your group, with your partners upon sample size or what's happening next in the next year for this project.
yeah. For the next year, our first harvest of our first crop for nutritional analysis is in 4 days. It's
Mm,
teff. It was a very dry year, and the teff was stressed, and a stressed plant thinks a lot about reproduction on a rapid timeline. They flowered and fruited early. For context, this is the 5th year in a row of drought in Ethiopia, the longest East African continuous drought. on record. And these mixtures we think are more important than ever. And it will be interesting to compare the mixed teff versus the pure lines of teff in this extreme year. So harvesting the mixtures, the PhD students are going to leave and interview farmers this coming month. The nutritional analyses should be done over the winter. And then for the next 2 years, we'll be doing the same thing again several times to check the reproducibility. But at the same time and into the future, we're looking to expand beyond Ethiopia. So we have study sites in Georgia, the country, not the state where you are.
In the Caucasus.
In the
Okay.
Caucasus, close to Turkey and Russia. And Georgia is very interesting because they've had a really rich tradition of mixtures. They're arguably the wheat diversity capital of the world. And they have mixtures, for example, of 3 different species of endemic wheat or 2 different species of other endemic wheats. But that practice is effectively dead. And so we're working with the Agricultural Research Institute there, which is essentially the USDA equivalent, to revitalize these mixtures and study them, do interviews with farmers to see what they remember. And then we have a budding project in Lebanon. Lebanon, in the southeast, you can still find farmers mixing grains. But
Oh,
interestingly, this is an area where you also find wild wheat and wild barley growing together, as well as wild oats. And researchers we've talked to there who study these wild grains or the wild relatives of grains say that you never find wild wheat without wild barley. So these species have been friends for tens of thousands, hundreds of thousands, millions of years potentially,
wow.
figuring out their relative niches and figuring out how to coexist. And so I don't think it's a coincidence that farmers in that same area decided to grow them together and spread them around the world.
That makes a lot of sense. As you're speaking, I'm also wondering what's happening within the rhizosphere of these crops as well. Like what's happening beneath the soil. We know that fungal mycorrhiza can play a role in communication and enhance survival of certain species. That's it's like there's
That's
so many more questions.
Yeah,
That come
that's the
after.
next for sure. We're figuring out protocols for mycorrhizae, looking at bacterial interactions, looking at carbon sequestration. And with the rhizospheres, wheat and barley have slightly different root structures and systems. So potentially you can plant them more densely because they're not competing as much at the same depth for the same nutrients. And as a result, really be more productive, harvesting more carbon dioxide from the air and the soil, the air pockets in the soil, and putting that into the soil. So if you scale this practice up globally, how much carbon would that sequester and help with climate mitigation, not just climate resilience? So these are more questions.
One last question, Alex. Out of these lessons that you've learned, do you have any favorite recipes that you've tried to make at home? I don't know if you can make your own homemade injera. I figure if you know how to do acorn bread, I was like, maybe you have some interesting recipes up your sleeve.
I've tried to make tej, the honey mead, Ethiopian honey mead. It didn't come out as well as the mead had in Ethiopia, unsurprisingly. Another thing is shiro, which is a stew or thick kind of sauce that can be made from chickpeas or fava beans or peas. And you can often go to Ethiopian specialty stores and buy bags of dried shiro. So I would definitely recommend that. It needs little more than hydrating and heating, and then it becomes a really delicious, they often already have the spices, which some of them are hard to find. So shiro wat is what it's called.
Shiro what? That sounds awesome. Tasty. I like just rehydrate and heat is something I can handle in my cooking repertoire.
Yeah,
That's great.
one dish.
Well, thanks so much for coming on the show, Alex. It was really great speaking with you, and I loved learning more about all the exciting work underway with this project.
Thank you. Thanks for having me. This has been a joy.
All right, listeners, you've been listening to Foodie Pharmacology, the science podcast for the food curious. I want to make sure that we thank our producers, to Rob Cohen and Christine Roth of Co-Conspiracy Entertainment. And thank you, listeners, for tuning into our show each and every week. If you want to find past episodes of the show, you can do so by going to foodiepharmacology.com. We've got a lot of great links up there for looking at not only some fun swag, but also video links and all of our old episodes. So thanks so much for listening. Stay healthy out there, and I'll see you next time.